to corporate stories on LinkedIn, YouTube, and maybe some other platforms, correct? Everybody is posting stories about how they got their first internship, their first job, how they cracked FANG, joined their dream organization, or started up their own venture. So, when you already have such inspirations and stories already available, then why today's session? It is primarily because I was getting bored on a Friday afternoon and thought to myself, let me gather a bunch of students and then give them some gyan and then bore them as well. And here you all are falling prey to my boredom. So, jokes apart, or maybe not, the story that I want to share with you all today is not about how I got placed or got my first internship or my job, because that journey might be very unique to all of us present here. And it would also depend upon your aspirations as well. Like some of you might want to join a tech company, some of you might want to start up, some of you might want to take up academia further. So today I'll try to answer another question that we have as students of technology, which is, will all of this that I am studying, will it be used somewhere? The 4 or 5 or 6 years that I am putting in to get this degree, to learn all these concepts, will it at all be useful in a professional setup? So, in today's session, I'll be sharing some anecdotes from my experiences and those of my friends and colleagues as software engineers, and the challenges that we face on a day to day basis, and some probable solutions to them. We'll keep this session very interactive. If you have any questions, you can always feel free to unmute yourself and pause me there. And the topics that we might be discussing today would be related to things that we study during our course of engineering. Yeah. So before we start our discussion today, I would like to ask you folks, do you think there is a difference between what we study during our graduation years and what we do as software engineers in a professional setup? And if yes, what that difference is? So you can feel free to unmute yourself and get the answers
Uh,
floating.
I think that it will be different because change is happening every day. So when we learn something old, and when we go to the industry, there may be something new, and we need to learn about it. And
Agree. Okay, so you basically want to mention that tech is evolving and there'll be something different that we might need to apply. Agree, valid point. Any other points? Anyone else feels differently or feels the same way or has any other points?
I think in college we mostly study most of the topics so theoretically deeply, but we don't learn to apply them in real projects. So
Mm-hmm.
that is the difference in industry and in learning in universities.
Okay, I think that's a very good point, and both these points are very valid. And these were some of the questions that even I had as student. Basically, some points of consideration, and my friends obviously also had these things. That will all this that I am studying. Will it be applied as is when I'm working as a software engineer, or will it at all be applied somewhere when I'm working as a software engineer? So, in today's session, I will be picking up topics one by one, which would be related to what we study as software engineers during our years of engineering. And we'll see how they somewhere related to my experiences in the industry, in the organizations that I have been working on, in the projects that I have picked up as a backend developer. And since we are all students of technology here, I have taken the liberty to err on the side of keeping this presentation and session to include some core tech topics as well. So let me begin with the first topic. And our first topic is databases. a nice pink bright slide flashing in your face is just attention seeking attempt at my end. So to begin the discussion on databases, what is a database? Any answers? Just a one liner would do.
Collection of required data.
Agreed. Database is an organized collection of data so that we can actually easily access it and manage it as well. And during our college years, we usually read about relational database. So you can organize data into tables, rows, columns, etc. So I'd like to share a story wherein I was working on a portal, and one of the modules of the portal was to list down all the users that we have in our system. Basically, a row wise listing of the users and their names, phone numbers, city, state, and some XYZ information that they had. For some reason, what happened was that this listing page became very slow to render, and sometimes it would not fetch any results at all. So we did a lot of triaging behind this, I and my colleagues, and first thing we checked if there were any network level latencies. We figured out that it was all fine because other calls or other operations were succeeding. We checked if our upstream services were working fine or not. Have they been reporting any errors? But even that wasn't the case. There were no errors or latencies reported from our upstream services as well. Then we triaged further, and when we started digging down further, we realized that our DB queries had become very slow, and a lot of them were timing out as well. And strangely, our database admin team and DevOps team also started pinging us about the same, and there was some increased memory usage as well, and we could not relate to as to why this was happening. We went through the code and we realized that certain database transactions were not being closed properly. So, before discussing further on this topic, I would like to ask if everybody is aware of what database transactions are. So, if any takers to explain to the group on what database transactions are.
Reads and writes to the database.
Sorry, I could not get you.
Reading and writing of the database.
Uh, yeah, it is reading and writing of the database. But what happens is in a database transaction, all the operations are atomic. Basically, a transaction is a unit of work that you treat as a whole. Whether so basically all the steps that are mentioned under a transaction, either they will complete all of them or none of them would complete. Let's say there's a particular transaction which says update city where name is Shreya. Next update statement is update country where name is Shreya. So, and if all both these update statements are mentioned under a transaction, if the first update statement went through and if the second update statement failed, so the entire transaction would roll back and none of these operations would take place. Basically, it is kind of an atomic unit. Either everything happens or none of it happens. So a classical example when discussing about transactions is transferring money from one bank account to another. So when you have to transfer money from one bank account to another, you have to ensure that the source account and the beneficiary account both have to exist. And if they exist, we withdraw money from the source account and then credit money to the beneficiary account. And both these operations should happen in a group. Basically, you can't say that we deducted money from account A but couldn't credit money to account B. So this is not a good experience. Actually, this is not something which is even acceptable. If you're debiting money from one account, you have to credit it to the other account. So this is what a transaction is. And SQL, the MySQL database that we usually study during our years, and the database that we were actually using at that time as well, guarantees that data in a transaction will be applied in a all or none fashion, as in transactional data cannot be lost. And so let's say we have an example. We have three users trying to perform some action on the same row. So let's say at T1, T2, and T3, each user 1, 2, and 3 respectively started their transaction. Uh, User 1 said that I want to update row 2 in table A. User 2 also said that I want to update row 2 in table A. But until and unless user 1 completes that action, user 2 will not be able to do that, which means that once a transaction begins, the database places a lock on that particular row that nobody else can read or write to this row until and unless one particular operation or one particular transaction, I should say, is completed. So if you see in the column 2 here, it says U2 is blocked by U1, and similarly it says U3 is also blocked by U1 because U3 wanted to delete row 2 in table A, but it will not be able to do it until and unless the transactions prior to it have been completed. So this is what we mean by what I mean by when I say a transaction is an atomic unit. So once U1's transaction is completed, the transaction is committed, the lock is released, and the next transaction, which was by user 2, that update completes. Let's say for some reason that update failed or something in that particular transaction failed, that transaction is rolled back, and only then user 3 can complete his or her transaction that they had been trying to do. So this is what I mean by when I say a transaction is an atomic unit. So, like I mentioned that in order to perform such transactions, SQL must lock the data that is being modified, and locking the data means that it cannot be seen or read by anyone else. So, since locking can block out other users who are trying to access data, the SQL carefully just locks one particular row which is being used, or n number of rows which are being used in a particular transaction. Now let us consider this particular transaction. Let us consider this particular update statement and assume that it was a part of a transaction. Update users set country equal to India, where ID equal to 15. And let's say this transaction is ongoing, it has not yet completed. So if someone fires another query saying select star from users, so such a query would begin a scan of all the rows, that row 1 yes, row 2 yes, row 3 yes, and when it reaches the row where we have ID equal to 15, this query will not be able to read that particular row, and it will have to wait till that point. And if the transaction completes, well and good. If the transaction does not complete, or the transaction remains open for a longer period of time, this select statement might even time out due to the default timeouts that we set in our database engine. And similarly, if we have a select statement like select star from users where ID equal to 20, ideally such a select query should be able to go through, because the only lock that we had placed was on the row where ID was 15. So ideally such statements should go through where ID equal to 20. But this is not a scenario which always happens. Sometimes you might not even be able to fetch data where ID equal to 20, and that is because when you acquire locks, what happens behind the scenes, it is actually using systems resources. This is the memory which the system cannot be used for any other processes. So if there are multiple update statements, each procuring their own lock, and we are not closing those transactions properly, and those transactions for some reason are open for a long period of time, So there are multiple locks on a particular table, and a lot of effort is being put in by the database to acquire these logs, and a lot of system resources are going into it. So what happens is there's something called log escalation, which is performed by the database. So log escalation is something that the database chooses. Like if there are a lot of rows on which I'm taking a log, so the database might place an intent to say, I'll take a log on this entire table because I'm using a lot of resources to take a log on on multiple rows of this table, and instead I would prefer to take a lock on this entire table. So when such a case happens, when the lock on the entire table has been taken, which means all the rows of that particular table have been locked, and more number of users are affected, more number of queries are affected, and the impact of this would be widespread. So this is one thing what happens when a transaction remains open for a longer period of time. Next thing related to transactions is please don't bother about what the technical terms or details are written here in this diagram. My main aim is to show that there is a transaction log which is maintained, and in the transaction log, whenever a transaction begins, whatever the steps of the transaction take place, that is logged into this particular transaction log, which remains in memory. And as soon as a transaction completes, the log actually notes down that okay, this particular transaction is completed. I can mark a checkpoint here that we can actually truncate this data or keep a backup of this data. Transaction log is actually useful in cases when we have to roll back a particular transaction, so we actually know that okay, these were the steps that I had taken. I'll go ahead and undo these steps. So if there is an uncommitted or open transaction that is present for long, the transaction log will continue to grow, and at a point we will not be able to truncate any data because the transaction never closed, and our transaction log file also kind of bloated or got filled in, and we have no memory left in the transaction log file to actually jot down the other transactions that are going to happen. So this is also one of the side effects of keeping the transaction open for a long time. So in this log file, what happens is once the transaction is completed, at regular intervals, there are several checkpoints placed, and based on those checkpoints, we write this data to the disk or some backup to actually maintain a log of what steps were taken on the database. But this transaction log file, which is used along with the database, it is a rewritable file. That is, we truncate data till the point that we have already used, and after that we go ahead and keep reusing it. So basically what I have been trying to tell you, that some theoretical concepts that we already knew with respect to transactions from our study of database during our graduation years is that SQL ensures that data in a transaction will be applied as a unit. To enable this, SQL must log that data that has been modified, and holding logs uses systems resources. When we came to the practical application of it, when there was a lot of load on our system, and the kind of load you'll only see when there is a big application running, when it is in production, it is being used by a lot of people. And the things that we saw was, if a lot of work has been performed, the system may choose to perform log escalation, more concurrent users will be affected, and open transaction will also keep the transaction log from being truncated. So these were our learnings based on the theoretical knowledge that we have. And now tying back to where I started, I mentioned that we were not closing transactions properly. So this is a small snippet of what kind of operation that we were trying to do. Let's say we started a transaction. In that transaction, I tried to fetch whether ID 15 exists or not. If not, I would say that I'll return. And if yes, I'll update the country for that particular data to India. Then using that transaction itself, I'll update the data. If the is not successful, that is, if there is an error, I try to roll back the transaction and then throw an error. Else, I try to commit the transaction and let's say return no error. So, where do you think the problem was in this particular piece of code? With respect to us not closing the transaction that I had mentioned earlier.
Database will get locked.
Uh, uh, could you please come again? Which line number?
Line number 4.
Yes, exactly. So here we are just returning without closing the transaction. Our rollback and commit methods were efficiently handling the closing of transactions, but we were not actually closing the transaction while returning from the error. So this is just a small piece of code. I tried to simulate that, but this was happening at a lot of places because there was a lot of internal error handling being done, which did not close the transaction, and this was the actual cause of us not being able to render the page properly, or sometimes having a lot of timeouts. So yeah, this was one of the stories. And actually this is the case where we were not closing transactions properly, and on similar lines we should not also keep the transaction open for a long period of time. So even if we keep the transaction open for a long period of time, we are trying to do multiple updates or multiple reads or multiple operations or checks within the transaction, even then we would be facing such similar issues. So in an ideal scenario, a database transaction, we should have one database transaction equivalent to per business transaction that we are trying to do. If the operation is to transfer money, it should just debit money and credit money to the source account. We should not try to be doing some reconciliation work also in that operation, and just keeping the transaction open for a long period of time. So this was about transactions, why our page was rendering slow. Please let me know if this made sense, or if I should go a bit slower, or should uh, redo this thing, or if anything you did not understand. Was this fine?
Yes, ma'am.
Okay, great. You can always feel free to pause me. So moving on to another story another related story, I would say, that I have. We had shipped in a new feature. It was quite a big feature. A lot of code had gone in, and what was happening was there there was no problem in rendering anything as such, but we were seeing a lot of slow queries that were taking a lot of time. And when you usually see slow queries, your the obvious answer is that success kit phase of, yeah, if there are slow queries, we need to have indexes in place. But as a matter of fact, we did index our columns as well. And before I take this topic further, I have a question again. What is a database index? Any takers?
It's like
Any,
cache or something.
you could say that in terms of cache, like it increases the speed, but it is not exactly a cache. Uh, any other answers to this?
Similar to index of a book.
I did not get you. Could you please repeat?
Similar to index of a book.
Yes, exactly. It is very much similar to index of a book. And so database index, it helps us improve the speed of data retrieval. So let's say if there are millions of rows and I'm searching for something, I cannot go on searching from row 1 to row n every time. That would take a lot of time and would lead to a lot of timeouts. So it helps us improve the speed of data retrieval, but there is also a cost included with creating index. That index will also take some storage, and additional writes would also happen to index. But based on the performance benefits that an index provides on a database, we always tend to use an index, and we should use an index when we know that our database is going to grow over the period of time. um, so let's say I have a table called my table, and I created a composite index on that table on columns a, b, and c. And when I have a select query of this type, select star from my table, where a is equal to, let's say, value a, b equal to value b, and c equal to value c. So this is supposed to use this particular index a, b, and c, and it will give me results faster. But what happens in cases when my where clause, let's say, does not have a equal to val a, and I'm just querying select star from my table where b is equal to value b and c equal to value c? Will this particular index still be used? The answer here is no, because SQL does a left to right scan, and in case it does not get the left value, will not even be able to reach B and C. And this is the particular thing which was happening in our case, that the order of columns in our where clause, basically the order in which we were querying in our where clause, was not matching with what the index was created on, basically the order of columns in the index. So SQL does a left to right scan while fetching data from the index, and this is what was causing the issues for us and the slow queries. And also one interesting thing that I came to know from our DB admin team, from where I was working on, was that while creating index also, let's say I'm creating index on a, b, and c, even this order matters while creating index. Ideally what we should do is we should create index in the order of basically the most selective column first and least selective column last. By this, I mean that whichever column helps us to truncate most of our data first, I should keep that first in my index, followed by the order in which from most selective to least selective. Basically, let's say if I have three columns, country, state, and city. So let's say just country and state. So country will have lesser number of options, state will have more number of options, and state will help us truncate more number of rows. So we should actually be placing the uh, state column first. I think this would not actually be a valid example, because state would be a one-on-one mapping, a many-to-one relation for a country. But what I want to say, that whichever column helps you truncate most number of rows, use that first in the index. So we made our query changes, and yeah, we were fine. A lot of queries were the queries that were slow began fast after making these index changes. But there was one particular query which was not working fine, or which was not working at a speed that is deemed acceptable. And that was when we were trying to do a search on name column. And when we looked at the query that we had built, it was something like select star from my table where name equal to this wildcard character EYA, and then again a wildcard character. So what happens is that this particular query was not even using the index that we had built on name. This is because most of the standard database indexes are just B trees, and B tree is a self-balancing tree data structure which helps us in faster data retrieval, I think in log n time, because it stores data in a sorted manner. So it somehow uses binary search, and if we do not have the start and end of a string, binary search would even not be useful in that case. So it ended up doing a full row scan also, and what we did was to rectify the situation, we removed the pattern based search for that particular period of time. So this was something that we did related to indexes. And just linking back these things, we knew from our theory that a database index helps improve the speed of data retrieval operations on a database table. It happens at the cost of additional writes and storage space to maintain the index data structure. And most standard database indexes are just B trees. What we realized during our practical applications was something which is built over these theoretical concepts only, but since we never had dealt with that amount of data, we did not face such issues. And when dealing with production data, we realized that index order is important, the query order is important, and it is not useful if start of search is not defined. So yeah, these were some of our realizations related to indexing. And so here I have another question for you. So you might know of a unique index. So what unique index does is uh, it only allows for unique values to be present in a column. Basically, you cannot have duplicate values in that particular column, the column which has a unique index. So once what happened was we had a unique column in one of our tables, and later on, due to some business logic change or business requirements, we had to remove the uniqueness constraint from that column. And when we did that, we dropped the unique index, and uh, everything worked fine on staging, etc. We had tested with some of our test data, but when it went to production, uh, all of our queries started to fail. Everything was timing out, and nobody knew what to do about it. So, any guesses what could have happened at that time? Why dropping that uniqueness constraint actually was giving us timeouts for most of our queries.
Because of collisions.
Okay, so there were no collisions as such because we had deliberately removed that uniqueness constraint. So that logic was handled inside our code, that what should happen in case there are duplicate values. So what happened was this column had a unique index. So the thing with the unique index is it is not only enforcing a uniqueness constraint, it is also an index. So once you drop the unique index, it is not just removing the uniqueness constraint from that column, it is also dropping the index that was present on that column. So uh, in retrospective, that we had what we should have done was we should have first created an index, a normal index over that column, and then drop the uniqueness constraint. And this was like this had caused a lot of issues for us, because nobody was even thinking, everybody was looking at the code, what all changes went in, and nobody sort of thought of key it could have happened because of one database query change. So that was a good learning for us. And also, just on a side note, we should not have too many indexes on our table as well. One, because indexes are costly, not just in terms of storage is not an issue these days. They are costly because the indexes are updated on every create and update operation. So if you have too many indexes, for every create and update, there will be too many re-indexing operations that happen. So I think, yeah, that is what I had to share on indexes, some of the experiences. Any questions so far? Anything that you might want to ask? Okay, I am taking that as no questions. Then feel free to pause me anytime. I'll move on to the next topic, which is data types. This is a small thing. Almost we feel that it is very trivial. Data types are basically the columns that we have in our database. To begin with, we have a primary key in our database, which is usually the ID column most of the times that we have. And when it is the ID column, we usually have auto increment type values, right? 1, 2, 3, 4, 5, 6, up till n, whatever our size of that particular column is. And for the ID column, we usually specify a method called auto increment while we do while we are creating our table itself, so that we don't have to every time fetch the last row of the table and do a +1 to it from our code. If you just specify create table and then put column name id, type integer, and write auto increment, it will always auto increment that id for you, and you don't have to pass that value in the database all the time. So the thing with id is usually a lot of us, what we are in the habit of doing is id, integer, auto increment. This is the three things that we write. But if it is auto increment, the value starts from 1, and then it will go up till n, till whatever the size of the column is. What we don't realize is that this integer type is a signed type, so it could have very well included negative numbers as well. So let's say if the integer takes 4 bytes, uh, so the number of values which were possible for that integer is 2 to the power 32. But since we also have to account for the signed bit, it will just be 2 to the power 31. So we are losing half of the range here. So in order to do this, we should always specify unsigned when we are using such auto increment values. So basically create table, and when we are writing column id, type integer, and then auto increment, and it should be of the type unsigned as well, so that we have the entire range available with us, and we're not losing onto uh, those numbers which were negative numbers, and since auto increment starts from 1, and will not be able to account for them. And also, but this is just something that I am telling you because we don't realize when we are creating a table. But more so in practical terms, it might not even matter much, because if you are exhausting 2 to the power 31 values very quick, there is a chance that 2 times of that also is not something which matters much when we are dealing with data on scale. So in that cases, there are other different types that you should explore, such as big int when creating the primary key, because the primary key will be ever increasing. And also, we might not be aware, but there are other types such as small int or tiny int, which we can use, and we should be using for columns which just store one value. Let's say we are storing some state which has a corresponding mapping in code, and we just want to store 1, 2, 3, 4, 5 in that. We usually just go ahead and create an integer type, but integer type takes 4 bytes, and we could have very well done this work with a tiny int, which I think just takes 1 byte. So these are certain things that I think we should keep in mind while designing a database. And database is something which should be designed keeping the future in mind. So we might have a current set of requirements, we will design a database, it'll work fine, but the database issues start happening when a lot of more feature requests come in, a lot of more data comes in, and at that point, database is not something which you can go ahead and change every time, or you cannot change the schema every time the a new feature request is made. So database should always be designed with a future vision in mind. That is something that I have to say. So once one of our teams also had faced a problem in one of my previous organizations, wherein their primary key limit exhausted and no new entries were getting created, and then a lot of data was getting lost. So these are some of the issues that happen with respect to database. So, like you mentioned, designing for the future. Are you aware of what the Y2K error was? I just got reminded of that. Are you aware of what the Y2K error was, or the Y2K bug?
Yes, ma'am. Actually, when the year 2000 came, the computers were designed that the maximum year will be 1999. But then Indian engineers came up with the solution that how to deal with the time greater than 1999 years. So that was Y2K.
Yeah. So this is correct. So what happened was, earlier, when between 1960s to 1980s, when a lot of software programs were being written, um, so the date column, they were just storing as the last two digits. Let's say the year is 1962. We'd only store 62 in the database and do away with the 19 portion of it. And what happened was, this was working all fine. And in 1993 around, some researcher realized that all this is going to fail when we reach 1st January 2000, because the database systems would consider 00 as 1900 and not 2000. So why everyone was storing just two digits of the year was because at that time storage was very costly. And when they were writing those programs, they never had in mind that, okay, this is going to be used in 2000 or something along those lines. And at that time, everybody, all tech companies or all tech products, started to take remedy measures as to what can be done. And at that time, I think it was a time for boom for Indian engineers, and a lot of business processing outsourcing that started to happen was around that time, when everybody wanted some remedy and cure for this. And I think there were not many errors reported when 2000 came, because most of the things had been fixed before the start of 2000 only. And there were, I think, just one or two issues. Some nuclear reactor had reported an alarm, nothing to panic, but there were some backup operations there, and something along those kind happened. Some ticketing company which used to give those bus tickets and all, I think there were some issues reported with respect to that as well. So this was the Y2K error or Y2K bug, or I think they called it the millennium bug as well. uh, yeah. So that brings me to my next topic also, which is authorization, another bright pink slide. Before I discuss this topic, I would want to ask, what is the difference between authentication and authorization?
Ma'am, authentication is authenticating a user by user ID and password, and authorization is authorizing a person for particular data.
Yes, that is very much correct. Authentication is just establishing whether you are who you claim to be you are. So it could be through means of password, like you mentioned, or through OTPs or biometrics or such means. So this is authentication, and authorization is more at a resource level, whether uh, are you allowed to access this particular thing or not. So that is authorization. And so I'll again share a story here. I was working, like I had mentioned, I was working on a portal, and we had a lot of data to render on that portal in different modules. But all that data and all those modules were not meant for everyone who is using that particular portal. So we had different roles created for that portal, that if you have role X, you will be able to see module A. If you have role Y, you will be able to see module B and C, and so on. And also different roles ensured that if you have access to module A, uh, do you even have write access on it or not, or do you just have read access on it? So such fine grained level of control was being managed through roles on that particular portal. And basically, while building that portal, anything that you would see on that UI would be resource controlled with a permission read write, and based on the roles, those permissions were assigned to that role. And let's say I am user X, I have admin right, I would be able to perform read write both on all the modules of that portal. So so this was I think I had been working on this particular portal for about an year, and I was like, okay, this is, and all this role handling and all was being managed by a different service altogether. I was like, okay, this is a service, it has a database, some code that we have written, it is interacting with another service to tell it that this person belongs to this role or not, and all that. But it was after 1 year, I think, that I suddenly had a realization that oh my god, this is role based access control that I had studied about in my cryptography class. So I had never actually looked at it from that perspective, that this is a RBAC design. I was just like, okay, database है, उसमें data डाल रहे हैं, वो बता रहा है कौन सा role है. And so yeah, this was a realization that I had in hindsight, that okay, this is something that I had studied. And while I was studying also, I had never thought that we are studying that for an application, because when you study role based access control, there was an entire chapter on it, and it was just telling things about that each role has certain permissions assigned to it, and users will be assigned specific roles, and based on that they can access XYZ thing. And I was like thinking at that time also, okay, this is common sense. If you don't have a role, you won't have access to that particular resource. But at that time, I think I did not see a wider picture, that it was laying the first principles of something which uh, I, let's say, an year later, I was working, and it was an entire service based out of that particular concept. So I'll just read out a snippet of what role-based access control is. Role-based access control refers to the idea of assigning permissions to users based on their role within an organization. It offers a simple, manageable approach to access management that is less prone to error than assigning permissions to users individually. So, if you think of it, if such user level permission had to be given, when designing this portal, whoever designed the portal, they could have even had the thought that okay, whenever a new user comes to our system, we could give them you have access to module A, module B, module C. But that would have been such a tedious process, because if you have, let's say, 1,000 users on your system, managing or checking that box every time that you have access to this would be very tedious, and it would be error prone as well. So that is why I think they had come up with this idea of creating entire service which would manage roles, and which was based on this role based access control principle. So benefits of role-based access control: it is easy to audit user privileges and correct identified issues. Basically, if someone says that I don't have access to this thing, you don't have to go to that user particularly. That user is assigned to a role, and if that user is facing a problem, you would know that there would be 100 other users as well that would be facing that particular problem. And instead of going and correcting it for 100 users, you can just edit the permissions for that particular role. It is uh, quick to add and change roles very well. Cut down on the potential of error when assigning user permissions, like we discussed. and more effectively comply with regulatory and statutory requirements for confidentiality and privacy. So when there are these compliance audits in a particular organization, at that time as well you need to tell that who has access to which fields, who has access to the user data, who has access to modify user data. All these become very easy and efficient when we have a role based access control mechanism. Any questions so far?
No, ma'am.
Okay, let us proceed. So since I'm working as a software engineer in a professional setup, so obviously we'll have or talk about concepts like distributed systems. And here I'll share another story here. I was working on a service which was dependent on another service to give us some data. Basically, what was happening was whenever in another service a new, let's say, user is created, it would push out that data to a SQS is a simple queue service provided by Amazon, and it would push that particular user to the queue, and our service would consume that data from the queue, just like a simple, how a simple queue would work. So what was happening was the origin service was pushing data to the queue, but and we were running workers in our system to read that data from the queue and write it into our database. But what we saw was we were seeing a lot of duplicate entries in our database when our workers were running. And but what we were also sure of was that the origin service is not giving us duplicate entries, because a user had a unique entry in a table that we were very sure of. So what we initially thought of was that our workers that are running or pulling out data from the queue, maybe they are not working properly, and two or more workers are reading the same data. So we put in some checks around that as well in our code. But even then there was duplicate entry. We monitored it for about 2 to 3 weeks, and we were just seeing duplicate entries there, and we had no idea about why that was happening. So uh, before going further here, I'll just read out some official AWS documentation onto what SQS is. So Amazon Simple Queue Service is a fully managed message queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. Using SQS, you can send, store, and receive messages between software components at any volume without losing messages or requiring other services to be available. Now, when we study about a queue, what is the first thing that we are very sure about a queue? What type of data structure is it? Uh, Basically, what is the prime difference between a queue and a stack?
Last in, first out, last in, last out.
Yeah, exactly. That is the correct answer. A queue is a first in, first out data structure that we are very sure of. But things start changing when we have implemented a queue, or when Amazon has implemented a queue in a distributed system. There are multiple nodes that the data would be distributed across, and a lot of problems that come in when we are dealing with a large amount of data, with data spread across multiple nodes everywhere. So the thing for queue that we were sure of was first in, first out. Okay. And also what we know about queue is whatever you put in the queue, you get out of the queue. There is no duplication happening in between the queue. But this is where things become interesting when you have a distributed system. So Amazon SQS also tells us that standard queues offer maximum throughput best effort ordering, and at least once delivery. So when we have implemented a queue, they're saying that it is a best effort ordering. They'll do the as best as they can to order the incoming messages and at least once delivery, which means that you'll get what you put into the queue, and they are saying that they guarantee that you'll get it at least once, but you can get it more number of times as well. This is something that we had never known before until we faced this problem. And just this one line of reading the documentation on AWS made us realize, okay, this is why it is happening. So then we put a deduplication logic at our end as well, uh, and then things started to work fine. So about a queue and about distributed system, from the theory we had the knowledge that queue is a FIFO data structure, but from our distributed system concepts we also knew that there are problems such as of high availability, eventual consistency, cap theorem, etc. uh, and then we, from our practical experiences, we came to know that standard SQS offers maximum throughput, best effort ordering, and at least once delivery. So there is also a FIFO queue which AWS sends, but what is the difference with that is that the number of transactions per second in that is limited. So they'll limit the number of transactions per second, and then they'll try to order it.
ట్యాక్స్ కాదు స్టాక్స్ అంటే నీకు తెలియదు అందుకే గమ్మ ఉండాలి.
Is someone saying something?
Go ahead.
Okay, sure. Thank you. So this was about a queue implemented in a distributed system, and it actually made us realize that uh, when things go to scale, they might behave a bit differently from what or how we expect them to behave. Moving on. So in distributed systems, how do we even handle load? Let's say my systems are working fine, or let's say Flipkart has certain virtual machines or instances on which their code is running, their server is up. But what happens when something like big billion days come up? Will their system be able to sustain that much load, or do we have to go ahead and manually add more instances every time a new request is coming? We are constantly monitoring. So how are those things handled? So what happens is, one thing is you can vertically scale your machine. So vertical scaling would mean you make your current machine or current instance where your code is running, you can make it more powerful, you can give it more RAM, you can increase the CPU power of it, but there is only a limit to which you can do that. So in that case comes in horizontal scaling, basically creating exact replicas of your machine where your code was running with the same code whenever the load is high. So this is also something which would come up when there is a lot of load. I think I remember we had studied things like vertical scaling, horizontal scaling while I was graduating, and at that time it did not make sense to me in terms of where will this be used. As in, if you're making a machine powerful, how would it even matter to create multiple replicas of it? But when I actually started working on AWS, when I actually started doing these things myself, then those things, in hindsight, I think made sense to me. Okay, these were the things that I knew of, and these are the things where it is being used. And also, so there is this concept called auto scaling, which AWS offers if you're using Azure cloud. Even there it is there, or any other cloud, but this concept of auto scaling remains. So what this concept says is, whenever there is an incoming load, you specify the threshold that if my CPU utilization increases beyond this particular percentage, get a new instance for me, or provision a new instance for me, so that code can run on that new instance as well, and the load would be properly divided between all the instances. So at this point one might even question, why don't we just initially put 20 instances or 40 instances based on the load itself, because there is a cost associated with it as well. It is a machine. You will receive your monthly or yearly AWS bill as well. All these things have a cost associated with them. So auto scaling ensures that you'll have n number of instances, or n number of instances will be added only when the load is high on your system, and once the load starts to decrease, all those instances will also start to go away and will be deprovisioned. So this is how a brief on how load is handled in a distributed system setup. Any questions so far?
No, ma'am.
Okay, I'll go ahead then. So since this is a software engineering course that you're studying, and there are a lot of software engineering models that you would be studying throughout this course, these models actually define how a software is built. Till now, what we went through was what will be the components of my software. There will be a database, what will be the issues associated with database, we'll have to manage distributed system things, and so on and so forth, multiple things related to the software components. But in a software engineering course, you also study about how a software should be built, because you're building that software for an end user. There will be multiple stakeholders involved. So and each software or each program or anything that you build will have a different use case, and it will be for a different purpose. And for that case, we have multiple models that you would be reading about, let's say waterfall model, or some iterative, multiple iterative kind of models. And today I would like to discuss one such model as well, which is the Agile methodology. This is an iterative software development model. And what happens in Agile methodology is, basically, I'll just tell you my life as a software engineer. What happens when my team has to ship out some features or build out new products that we have to do. And this agile methodology is something which is very commonly used these days in a lot of tech and product companies. So what happens is we work in 2 week sprints. A sprint is something where we decide what we want to ship. We do the coding of that. We interact with our stakeholders during that, and at the end of that particular sprint, we ship out a product. So this is how it works. And for a sprint, there are certain steps that are to be followed. Step number one would be product backlog creation. Basically, there'll always be a product backlog, whether you are starting out a new product or whether you have already shipped out a product and you want to add new features. So what a backlog has is, what are the next things that we can do for our product. And this backlog also maintains the priority of that particular ask or that particular requirement. Basically, a backlog is a set of all the requirements for my product. So once we have this backlog, one day is for sprint planning. What we do in the sprint planning is, out of all the available items in our backlog, which ones do we want to prioritize for this sprint? This could be based on multiple factors, whether it is a tech debt, as in we are not able to do a lot of things in technical terms, or in performance improvement for our system terms, and we need to pick this item, or there is a pressing user ask to ship this item. Based on a lot of multiple factors, we decide which particular items we will pick up in this particular sprint, and then we create a sprint backlog. Basically, from that entire backlog, we create a sprint backlog. And once that sprint backlog is created, we assign those tasks to each of the engineers in the team based on their bandwidth, based on what they are already working on, or if they have any prior commitments. So once this assignment is done, then begins the development phase. The developers of the team, they begin to code, they interact with other team members, or if they want to seek any more product clarifications, they do that in all this time. And once the development phase ends, you send all your changes to be tested, and either you test those changes, or if there is a QA, a quality assurance assigned to your team, either they will do the testing of those changes. And once those changes have been QA approved, at the end of the sprint you ship those particular features. So what happens is, and once you ship those particular features, though that sprint is closed, and this cycle repeats. So if you see that this is an iterative process, wherein every time you gather requirements, you prioritize, you build, you test, you ship, and then this process repeats. So most tech companies or most product companies would have this same methodology, and this is called the Agile methodology. And what we have in Agile is that the end product of each sprint would be a usable product. You cannot go ahead and saying that this sprint we our product will stop working because we're working on some bigger features, and next week and next sprint mein jo hamara product aayega, that will be like super cool, so this week will not make it work. So that is not how this happens. In Agile methodology, each sprint, whatever you ship, should be a usable product, and it will be building on incrementally, just like you see in this picture. If a user requirement is, I want a vehicle in which I can travel with my family. If there is such a requirement, you cannot go ahead and give them just a wheel पहले दिन कि अभी आप ये पहिया रख लीजिए, हम will connect it and we'll slowly and incrementally give you something. You have to give them something. You have to start with a minimum viable product that first you provide them with mobility in some manner, and then you build upon it iteratively, gather their feedback, just judge if their expectations have not changed in between, and then modify your sprint as well accordingly. So all this that I mentioned right now with respect to Agile methodology is how you build your software when you're working with a diverse group of teams and users, business, everything is involved, and this is how this works. I can even show you a small board. So this is one tool which can be used for an Agile methodology based team, let's say a Scrum team. Are you able to see this particular screen?
Yes, ma'am.
Okay,
Yes,
great.
ma'am.
So, like I mentioned, we have a product backlog. Let's say I already have a backlog created that as a user I should be able to list all products. As a user, I should be able to search for more products. As a store owner, I should be able to add more products to my store, etc. So, this is a list of features that should be present in my app or on my e-commerce website, or whatever I'm building. Out of these features, I have to decide based on the priority and based on other expectations and reasons, which of these can I pick up in one sprint. I cannot deliver everything at once. I have to start with a minimum viable product and then build on it incrementally. So let's say I have a sprint already created. I I'll definitely have to provide the users to be able to list all the products. I'll definitely have to give them an ability to search, and for store owners, I'll also have to give them the ability to add more products and remove products. As a store owner, I should be able to customize the background. So this is a good to have feature, not needed for an MVP, I would say. Also, as a user, I should be able to mark my favorite stores. So even this, from a user's perspective, would be a good to have feature. It will not block them from performing their current operations. So for an MVP, I think let's say these 4 things should be good enough. So what you do is, once you have decided on which items to pick up initially, then you can assign those to members of your team. Let's say I assign this to me, I assign other tasks that are other user stories, we call them, other user stories, to other members of the team based on the amount of time that they have or amount of time they will be available for. And these tasks are divided. And once you have done this for a particular sprint, once you have done the task assignment, each developer can individually go and add tasks to their particular user story. Let's say for implementing this particular feature, as a user I should be able to list all my products. I might have to set up a database. I might have to establish connectivity with some other service as well, and whatever the things are. That is something that each developer does at their end during the development phase. And once you have done this, you can start the sprint. You can set the duration of your sprint, and this is how your sprint board looks like. So any agile methodology team or a scrum team, they usually have daily check-ins where everyone tells what they did the previous day and if they are blocked on something or not, and basically discuss the status of the tasks assigned to them. They can move it to in progress or add other columns in QA, in testing, whatever they are working or however they are working on. And at the end of the sprint, the aim is to have all the items to a done state. That is an ideal case scenario. So this is how agile methodology works. And once the sprint is closed, you can start another sprint, pick up more items from the backlog, etc., etc. So this is one such tool. There are multiple tools available, and each organization uses their set of tools, but the end goal remains the same, that each sprint you have to deliver something which is functional and which is an incremental improvement on the prior state of the system. Any questions here with respect to agile methodology or anything? I'll take that as a no and I'll move on. So having discussed all the things,
Please
yeah.
check the chat box.
Shreya, there is a question in the chat box.
Okay, let me just. When building a system from scratch, based on what parameters can we decide which cloud services should be used? For example, you mentioned about SQS. There are other alternatives as well, such as Kafka, RabbitMQ. So how did you decide that SQS would work best for the system? Okay, that's a very relevant question. I think these decisions are dependent more on what other components you are using as well. So let's say if my team had already been using AWS products, so in that case, it'll offer me ease as a developer to get that connectivity, to get things set up. And while building from scratch, it also depends on, since these things come with a cost, what your cost model is, how are the things that how is your product going to use basically these services, the other services as well, not just one thing. So if I have a system on AWS, and if there is something that I find which is good on Azure, it would be difficult for me to get that connectivity rather than using something which is already present for me. So that is one of the criterion. And the other thing is doing a feature comparison, I would say. What all things does, let's say, Kafka offer to me? What all things does SQS offer to me? SQS, there is a dead letter QA and all as well, which we were using for some of our use cases. And basically, the time taken to integrate, the cost which I can afford, and what are the plus or extra features that I am getting with it is something which we would usually consider. Did I answer the question, or are there any follow-ups? Any further questions? Let me check the chat box again. Okay, thanks, Nishit. I guess we'll move on to the next slide then. So, yeah, I was saying that these were things related to the software components, the way we are building our software system, how we are interacting with different teams in a software engineering environment. But there are certain things which are intrinsic to you as a developer, which is something that you would have to do for yourself to be able to work in such a setup, to be able to use whatever is present around you. So to begin with, so we have this tech jargon, a lot of words, a lot of new technology coming in. Every few months there will be something new, and I found this really nice picture on Reddit where this person says, I typically ask recruiters to point out which of these are Pokemon on their LinkedIn profile. So yeah, this is something which will happen to you as well. There'll be a lot of new technology coming in every few months. You obviously can't learn everything, but that does not mean that you should not have the ability to learn everything. So you should always try to keep yourself acquainted with what is going on around you. So I'll give you an example. When I was in my final year, I was doing my thesis work. Most of our batchmates, we were working on some machine learning project, or some sort of machine learning project, some text analysis, or let's say some prediction or something along those lines. Within a year, when we graduated, our next batch, most of the students were working on blockchain, because that thing had caught up during that year. And so most of the projects started to come on blockchain, and that happened within a span of 1 year. But since we did not make a project on blockchain, that does not mean that we do not have the ability to understand any project that is made on blockchain. For that, what you have to do is you just have to stay acquainted that there's something called blockchain. This is how it works, and if in future I have to do something on this, I will be able to do or I will be able to carry out that project. So yeah, that is something that you should always have in you, that will to learn. And if you are in the tech domain, you will have to constantly learn, because after a point, whatever you know, the technologies that you are working on will become redundant, will start to become obsolete. But the fundamentals, the underlying theory behind it, that is something that might never change. There can be modifications on it, there can be a lot of optimizations which would be done on it, but there are certain things that would never change. Just a newer tech is something that could be coming. Another example, let's say I was working on Golang. So before that example, so I have worked on Golang, Kotlin, and Ruby throughout my career journey in the organizations that I have been working on. But these three were not the languages that I had ever used during my graduation life. So how did I learn it, or how does anyone learn it? Anyone learns it because they know what the underlying principles behind learning a language are. There are certain things which will remain constant for any language that you learn. Just the syntax would be different. There would be some fancy things in one language, some optimizations in the other language, but how that language behaves or what the purpose of that language is would still remain the same across multiple languages. So yeah, continuing with my Golang experience. So while coding, or while implementing something, I had to use an XOR operation between two booleans, and strangely, Golang did not support an XOR operation between booleans. I don't know what that inverted V kind of thing that we use, right? That was not supported. So that does not stop my work there, right? I, as an engineer, know that an XOR can be implemented using and not an ORs, because these are the basic operations. So I went ahead and implemented it using and, or, and not, if I could not use an XOR directly. So uh, again, the first principles remain the same. It is something that you would build over it, and you'll have to keep yourself acquainted with the changes in the tech as well. So this is about the tech jargon, and also design thinking. Design thinking is something which is composed of both, I would say, critical thinking and creative thinking. So critical thinking is that side of your brain which determines how you judge things, how you weigh things, or maybe how you analyze and break down things. And the creative thinking side of your mind helps you create things, create new things, or invent new things along those lines. So whatever work you do should be a mix of both of these things. You should be able to confidently say when your critical thinking side of your mind should dominate, or when your creative thinking mind should dominate. So, so this is just an example of creative and critical thinking. I'll also give you an example from my previous experiences. We were actually working on a system, and there were a lot of if else conditions which were controlling. If this happens, the user should move to this particular state. If this happens, the user should move to this particular state. If it moved to that particular state, if this happens, the user should move to XYZ state. And it was a very complex diagram, and it was not even a sequential call. There were some things that would happen behind the scenes when we receive a call back from some place, etc. So we had time in our hand. We could have just gone ahead and added more if else conditions to that particular thing. But since we had time, we decided, why don't we build a state machine out of it? State machine is something that I think I had studied in my graduation years while I was in the course of compiler design. That is the first time that I had come to know about state machine. After that, never used as well. Once this problem came to us, we were like, okay, let's try to implement a state machine. And this was both judged by the critical thinking and creative thinking side. Why? Because uh, the creative side of mind says that you have to do, you can create this, you can do this, but it should also be supported by the time constraints or the organizational constraints that you have, or when you have to deliver that thing. And since we had time at our hand, we went ahead and implemented a state machine. And after that, I think that if else thing was almost forever gone, and adding a new state to our system, or adding a new transition to our system was very easy. That is something that happened. Similarly, we had a case where we tried to implement a decision tree as well, just to guess which particular state a system should, a user should be in. Yeah, so that is it from my end. From those were the experiences that I had to share. Any other questions, or we can move to the assignment? Any questions? Yeah, because what is a session or what is a lecture without no assignment? Okay, so the assignment is just this. You can go to this website, and when you open it, it'll throw you a word, and you just have to guess whether it is a Pokemon or a big data. So this is from my end. Thank you, everyone. I'll just stop sharing, and if there are any other questions, I'll be happy to take them up.
Any questions? Right. So much of learning you have shared, Shreya. Um, I understand that compacting the learning into our session in the 3-year period is not always easy, but I'm really grateful that you have thought so much behind this presentation to share with students. You know, they will get a perspective right while being in college. Not to get intimidated, of course, by all these technical terms, but to have this idea that software engineering or software development is an empirical process. You learn as you experiment, you identify the bugs, you identify the mistakes. So mostly you're learning by hit and trial, and then again trying to arrive at a standardized way of doing things and understanding things. So that perspective was very much clear from your presentation, and I'm really grateful for that. And again, uh, academic institutions cannot be expected to teach students everything about industry. And industry, again, has its own set of things to do. So that's why we invite people from industry, so that there's more of a collaborative learning, so that what we didn't know when we were in college, the students can know much better, and when they go forward in industry, so it really helps them. And I know that they may not have understood everything, but the concepts and the terms that you have used may have triggered certain portions in their brains, which they might reflect on later on. And again, technology becomes redundant very fast, so that is why fundamentals are important, and you have reinforced that point. So sometimes it can be difficult to bring students to fundamentals. Most of the times they want to implement and code and program, which is also easy, but then again, a solid grasp of fundamentals in any field is very important. And so I normally I don't speak much after the guest lecture, but in this guest lecture, I myself have found such excellent things that you have talked about. So I'm not able to stop myself to speak all this. So again, to the students, I would say that don't get intimidated by the inundation of knowledge. Try to look at it as exposure. So you don't have to become best in everything. You just try to learn through the projects that you are doing. And in fact, this morning I was reading a book in which the author was saying that to master any field, you need mastery of theory, and you need mastery of the art of doing it practically. But more important than that is the utmost interest in learning that art. So uh, that's what, and I completely learned a lot from your guest lecture, Shreya, and I'm so happy that your experiences you have been able to share, and it will help students definitely going forward. And we will want to keep this channel of communication open with you and with GitHub. In fact, we have been talking to GitHub campus program. Yeah, yeah. So the team has approached us in IIIT Pune to establish their campus program here. So we are in the process of doing that. So, I mean, I'm feeling very happy and fortunate that you have spent your time with us today. And I notice you did not drink water in between. So after the session, please hydrate yourself properly.
Thanks a lot. Thank you, ma'am. And I am really happy to be here and to be sharing my experiences with the students. So my main aim was not to tell about what all technologies or what all things that we have been using. Just the aim was that whatever you will be doing, whenever you try to reflect, you will be able to relate it with something that you had studied or that you had experienced.
So again, the central message is to be curious about what you are doing rather than feel bogged down or intimidated when the errors or mistakes happen. So that kind of attitude really plays a lot more part in any field, be it software engineering or anything else. So with that, Shreya, I mean, thank you is not enough, but I'm really happy and extremely
Thanks
grateful
a lot,
for
ma'am.
spending time here. Thank you so much.
Thank you. Thanks a lot, everyone.
Excuse me, ma'am. But how is the life at GitHub? Is it enjoyable or pressuring? Or,
Oh, I am enjoying my time at GitHub. I joined GitHub, I think, in January this year, so I haven't been able to meet my team because of the work from home scenario. But even on calls, etc., whenever we meet, I am absolutely enjoying my time, the type of work that I'm doing, and moreover, the philosophy of open source is something which I am very excited about, and that is something that I like. And yeah, I'm enjoying my time.
thank you, ma'am.
Anyone else wants to say anything? So thank you so much, Shreya. Thanks a lot.
Thank you. Thanks a lot. Bye bye, everyone.
Bye, ma'am.
So I hope the session was a bit useful to all of you. And my again, the intention was to introduce you, to the some of the concepts that you learn. But I think if you have to take important understanding from here, and I wouldn't take much of your time, it's that we learn by doing. So that's the thing. So always try to keep this philosophy in your life, even in your projects and in the subsequent lab sessions. That will be our endeavor. So thank you so much for your time today, and I'll see you on Monday. Thank you so much.
Thank you, ma'am.
Thank you.